This laser is passing this plastic sheet, as you can see. But there's a smaller portion which is reflected. If you want to find out what this has to do with the design of an optical network, just stick around and we'll check it out. So today we are talking about insertion loss and return loss. First, let's have a closer look at the insertion loss, and simply speaking, it's the loss of power from the input power to the output power. Depicted here is a fiber with connectors and all that stuff, and we have the input power, the output power, and the insertion loss is calculated 10 times the logarithm of input power divided by the output power in dB. Now the question is, what are reasons for insertion loss? This can be absorption, it can be reflection, but it also can be banding or misalignment. To give you some examples for insertion loss, a single mode connector has 0.1 dB, or 1 kilometer of fiber has roughly 0.3 dB. Keep in mind, the insertion loss is one big ingredient for the calculation and design of your optical network, especially for the link budget. I talked about the reflection and as a cause for insertion loss, but this is also one of the main causes for the so-called return loss. Return loss basically describes the amount of light that is reflected from the optical system back to the sender. And here depicted we have once again fiber with connectors and all that stuff, and we have the input power P in and we have the return power P red. The return loss as it is a bad thing. So we want to have a high number in this return loss as it can harm or destabilize your system, your lasers, and especially in coherent systems that can be a problem. The calculation of the return loss is quite easy. It's similar to the insertion loss, 10 times the logarithm of P in divided by P returned in dB. The question is, what are the reasons for return loss? This can be backscattering, this can be a bad connect or open fiber, but also in free beam optics, this can be the step in the refractive index at interfaces, especially if you forget to use an anti-reflection coating. To give you some examples, an open fiber or connector has a return loss of 14 dB. Or a 4-channel MUX can have 45 dB. So once again, to have a low return loss is a bad thing, as it can harm your optical system. Now, to summarize the said things, we have the insertion loss on the left-hand side, we have the return loss on the right-hand side, and once again, insertion loss is the power lost going through the system forward. And so we want to have a low insertion loss, as we need as much light passing the system as possible. If we're talking about the return loss on the right-hand side, this is the amount of light which is returned from the system. And as this is bad for your optical system, we want to have a high return loss, meaning we want to have the least light returned from the system what is possible. I hope you learned something today. If so, please leave a comment and see you in one of the next videos. Bye bye!